In this video, we are going to talk about the following interview questions, but before starting, do check out our first 3 videos to get better understanding. Please find the video links in description. Now let's start the video. Here our first question is going to be a scenario based question where I have a requirement to copy a config or you can say a token file inside a container, but the limitation is that I can't use any Docker command for that. So is there any alternate way to achieve it? Here, intention behind this question is to check your knowledge on Docker. One thing which you need to be very clear about is that Docker shares resources from your host for running any container, be it your CPU, memory, disk, or network. It means whatever changes are happening inside your Docker container are actually written somewhere on your host machine. So you just have to find that folder location and copy your content over there. And then it will be automatically visible inside your Docker container. Now let's do it in practical. I am here on my Docker host. I have a running container over here which is test1, and I have to copy this content inside my container. So first I'll get the folder location where my container specific changes are stored. Docker inspect test1. It will give me all the details about my container, and you can see this is the location where my container specific changes are written. I will copy the full path from here. Now I will go to this path and I will copy my test file over here. You can see my test file is present now. Now let's go inside the container to verify the same. So docker attach test1. We are inside the container now, and you can see one test file is present over here. Let's see the content of this file. So this file has the same content which we copied on our host machine. So this is how you can copy any file inside your container without running any Docker command. And also this approach can be used when you want to copy data from one container to another without copying it on host machine. Moving on to next question. It's a statement which says I can run any Linux flavor container on my host as Docker Engine makes use of Linux kernel features for containerization. First, we need to see if this statement is correct or not, and if it is correct, then we have to prove it. The given statement is true. Let's see how we can prove it. First of all, let's check the OS flavor and kernel version of my host machine. Cat etc OS release. So flavor is Ubuntu and kernel version is 5.4. Now let's get into the container. Docker attach test1. Here my kernel is. Here you can see the kernel version is same for my host machine and for my Docker container. Now let's check the OS flavor. etc OS release. My container OS flavor is Alpine, but on my host the OS flavor was Ubuntu. Hence we can say that the given statement was correct. Moving on to our next question, which is again a scenario based question. Here I am running a container which accepts user inputs, and based on the user input it has to work with Docker images, or it has to stop or start a container on my host machine. In other words, it has to talk to my Docker daemon from inside a container. So how we can achieve it? To address this use case, you need to know how Docker daemon really works. Let's understand it by a diagram. When you start a Docker daemon on your host, it opens a Unix socket with the name docker.sock and starts listening for the user instructions on the socket. Docker API and Docker client use this socket to interact with Docker daemon. We will use the same socket to fulfill our requirement, where we'll mount this socket as a volume inside our container. By doing that, we can start interacting with our Docker daemon from inside our Docker container. Now let's see it in demo to get a better understanding. Here I am on my Docker host command line terminal. Now let's start a Docker container by mounting Docker socket in it. Docker run -itd-v, where run docker sock. Again, where run docker sock hyphen name docker. I will use docker image as it comes with pre-installed docker client in it. Docker. So container is created. Docker ps. Yes. Now let's get into the container. Docker attach. My container name is again docker. Now I am inside my docker container. Now let's list the running containers on my host from inside the container. So docker ps. You can see I'm inside my container, but from here I can interact with the docker daemon which is running on my host. Here we are getting the same output as above. It means I am able to interact with my host docker daemon from inside the container. Now let's try running a container on my host from inside this container. Docker run -itt alpine. Let's list it. Docker ps. So new container is started. Now let me come out of this container and see whether this new container is actually running or not. Now I am on my host machine. Let's run docker ps. Here you can see this is the container which we started from inside the container. So this is how for different use cases we can interact with our docker daemon and run different commands on it. Moving on to the next question. Stopping a running container using docker stop is slow as compared to docker kill, but still it's advised for a good user experience. Why? These kind of questions can be asked to know your understanding about what happens when we run these kind of commands. First, let's see what Docker really does when we run these commands. Here I have opened two windows. First window I will use to check Docker events. Docker events. And I will run docker kill and docker stop command in my second window. First, let's list the running containers. Docker ps. Now I will kill my test1 container using docker kill. Docker kill test1. So docker kill command has sent signal 9 to my container, and this signal 9 can be used to abruptly stop any process. Now I will stop my second container using docker stop command. Let's record the time as well. So time docker stop test2. Docker stop command took around 10 seconds to stop the container. Now let's see the docker events to know what happened in background. So at first my container received signal 15. Signal 15 means sync terminate. This signal is used to gracefully stopping a process, and then signal 9 to stop the process. So between signal 15 and signal 9 there was a 10-second time to handle any ongoing request so that my user doesn't get a bad experience. So this is the reason when you run docker stop command, it takes some time to stop a container because it gracefully stops a container after handling all the requests. On the other hand, docker kill command doesn't care about the ongoing request, it abruptly stops the container. And this is the reason it is always suggested to use docker stop command instead of docker kill. Moving on to our next question, which is a scenario based question. Here I have an app and a DB container running on the same host. Then how can these two containers talk to each other? See, there are different ways to make this communication happen between two containers. Here we will see few of them. First one is using link flag if your containers are running on the default bridge. Second and the most recommended way is using user defined bridge. In this case, you should create your own bridge network and you should run your containers in that network. So that's it for this video, guys. If you liked the video, then do hit the like button and subscribe to my channel. Thank you.